Hi, I'm Behnam Jafari and welcome to your channel. Today we will practice input and output functions with 6 exercises designed to make your coding smoother. In this series, we focus on the most useful parts of the C language for microcontroller program. Exercise 1, reading inputs from the keyboard using a scanf. Exercise 2, reading an integer using a scanf. Exercise 3, reading a string and an integer simultaneously. Exercise 4, using puts to print a string. Exercise 5, reading a full line of input with fgets. Exercise 6, using putchar to print a single character. If you are ready, let's go. Exercise 1, reading input from the keyboard using scanf. We start by clearing the contents of the main function. Then we define a string variable that can store 11 characters plus the null terminator. Using printf, we display a message prompting the user to enter a string, appending /n at the end to move to the next line. Next, we use scanf to read a string from the keyboard and store it in the str variable. Finally, we print the entire string to the console. To manually pause the debugger, we add an infinite loop while 1 at the end of the program. After compiling the code, no error warning appears. We then debug the program. Previous videos cover the debugging process in detail, and the link is available at the top of the screen. When we run the program, a message enter a string appears. We type hello world and press enter. However, the output shows your string is hello. The reason is that scanf reads input until it encounters a white space, such as a space or enter key. This hello word contains a space only. Hello is stored in the variable. Exercise 2, reading an integer using a scanf. We define an integer variable named var, then prompt the user with enter an integer number. The /n ensures the cursor moves to the next line for input. Using a scanf, we read an integer from the user and store it in var. The %d specifier tells scanf to interpret the input as an integer. If we forget to use ampersand sign var, a warning appears because scanf expects the memory address of the variable. We switch to debug mode, run the program, and enter a number when prompts. If /l is included inside the scanf, it may interfere with input handling. Finally, the entered number is displayed using printf function. Exercise 3. Reading a string and an integer simultaneously. We prompt the user to enter a string followed by an integer using printf. In scanf, we use two format specifiers. %s reads a string and stores it in str. %d reads an integer and stores it in var. Important note, for string variables, we do not need the ampersand symbol because a string's name represents the address of its first character. We input hello world followed by a number, but the program outputs 0 for the integer. This happens because hello world contains a space, and scanf stops reading the string at the first white space. The integer input is therefore not correctly read, causing an issue with the input. To handle multi-word strings, we should use fgets instead of scanf. Exercise 4. Using puts to print a string. We use puts to display a message. Puts hi everyone. Unlike printf, puts automatically moves to the next line after printing. If we declare a variable but do not use it, the compiler issues a warning. In embedded systems where RAM is limited, it's best to comment out unused variables so the compiler ignores them, improving memory efficiency. Exercise 5. Reading a full line of input with fgets. The fgets function reads a complete string even if it contains spaces. Its syntax is shown on a screen. Fgets str is the string variable to store inputs. Num defines the maximum number of characters to read, including the null terminator. String specifiers the input source, typically stdin for keyboard inputs. We prompt the user to enter a string using puts, then read input with fgets. Since str can hold only 11 characters, entering more will truncate the input. Since str can hold only 11 characters, entering more will truncate the input. In embedded system, memory management is critical. If memory constraints are relaxed, we can increase the buffer size. You can see a string with 100 characters. This allows longer strings to be safely stored. Key difference between scanf and fgets. Unlike scanf, which stops at the first space, fgets correctly reads entire sentences, including spaces. Exercise 6. Using putchar to print a single character. The putchar function prints a single character to the output. We should use single quote inside the function and a letter, or alternatively, we can use an ASCII code inside the function. Here, 65 is the ASCII value of letter A. This function is useful for handling character-based output, especially in low-level programming and embedded systems. Thank you for your watching.